Okay, I've done a quick overview of this book, or preview, I should say. I've given myself a quick preview of this book to kind of just load up into my brain what to expect, right? It's a lot of this is about creating texture in my brain for information to stick to. And now it's time to get into this chapter 4, where basically it seems to me this is the chapter that teaches us some NumPy. Now, first I want to do a look at the table of contents of this chapter. So we've got the ND array, the multidimensional array object. So we're going to learn how to create it, the data types for it. I guess it needs special data types. This is why we do the preview. We can kind of like question. I remember when I was a kid, I had this psychology book, and it started off by telling you, I think it was called the SQ3R method. It was like survey, question, and it's probably like read, review, whatever. But, I certainly do the surveying and questioning. So data types, so I'm assuming ND arrays. I'm thinking the ND arrays need special data types for it all to work. Arithmetic with NumPy arrays, basic indexing, slicing, Boolean indexing. That Boolean indexing and fancy indexing, I don't know what that means. That's cool. Transposing arrays and swapping axes. That's cool. All right, pseudo-random number generation. Cool. Universal functions, fast element-wise array functions. A universal function. Okay, so universal, it's not like a list of universal functions. It's like there's a thing called a ufunc. Oh no, there is a list of them, such as square root and exponent. I wonder if we can implement our own. Maybe you have to do it in C. I'm not sure. There's unary and binary. These guys. Well, I am almost positive that whoever created NumPy is familiar with APL. Like I think I even read that somewhere. I'm not sure, but so of course they use the term unary and binary, not monadic and binary, but monadic and didactic in J and APL, but yeah, still very kind of like similar because it's array based. And here we go, array oriented programming with arrays. That's cool. Array oriented programming with arrays. And we're going to talk about expressing conditional logic as array operations, which is what I said I'm interested to learn. Mathematical and statistical methods for Boolean arrays. Interesting. What's going on with Boolean? Like, what's an array of true and false, and it has certain methods? There's definitely a reason for it to exist. I'm interested to know, why do we have these Boolean arrays? Sorting, unique and other, set logic. Okay, and set logic is something that I need to learn. I need to get better at set logic because I really want to get good at Alloy, which is a modeling language. And that modeling language, Alloy, is, I think, all about set logic. I think it's like the whole thing of Alloy. It's really just like a way to express set logic. It's not really just that, but that's like, it seems to be the foundation of it. From my understanding of Alloy, which, obviously I'm not an expert. Expressing conditional logic as array operations, blah, blah, blah. So, okay. File input and output with arrays. Okay, whatever. Linear algebra. Cool. Now we're just going to get to this and we're just going to do some linear algebra, and we're not going to claim to be good at actual, like, to really know it. I'm not going to claim that I know anything about linear algebra. I mean, I know kind of what it is, right? Like algebra done on these multidimensional arrays and things like that, but I don't know. I'm not a mathematician, but we'll get here and we'll just try to write the code. And we have an example. Cool. So we get to an example. I don't think prior to this we had any examples. So we're going to get to our first example. And then that makes me wonder, where's the GitHub? Well, if I come down to here, I just remembered here was the link to the GitHub repository. See why it's good to do the preview and just good to know what's in your documentation. So I'm like, oh, what's the GitHub repo? Instead of searching for it, I know that if I come to chapter 13, data analysis examples, it's going to give me a link to the book here. All right. And so, yeah, there are examples for chapter 2 and whatnot, but they're just dumb. Okay. I mean, not that they're dumb, but, you know, in the book, it's only in chapter 4 that we start getting into examples. Random walks. The simulation of random walk, we can learn about what that is. And the interesting thing here will be doing it in the pure Python way and then seeing the difference doing it with NumPy. So that'll be great. And so this will be probably some code that we're going to want to come back, and this might be some of the code that we read, you know. I mean, all throughout this, here we have code that we can read. So we're always going to be reading code, but when it's time to say, hey, let's learn by doing a close reading of some code, maybe we can come here to the chapter 4 notebook. Yes, I do watch Blue's Clues with my child, and I did watch it as a teenager. Here we go. Example, random walks. Simulate. Anyway, we can kind of. This is definitely enough code to read. This is probably even a good place to start, just reading a little bit of code. All right, cool. So we did it all. Let us go. All right, so I'm just gonna get started. I'm not as comfortable. I wish, you know what, I can at least pull this into its own thing. Okay, I would like to have a text editor. This is fine. All right, so we're going to import NumPy. Woo! And what are we doing here? Oh, as NP. That's how they do it, huh? So we give it an alias, NP. That's fine. That's probably pretty standard, so we'll just go ahead and do it. And then we're going to create some data and whatever. So now you could copy and paste this. I'm going to write this out myself just for the sake of kind of getting it under my fingers a little bit. And they call this thing data. So yeah, we're doing data analysis. You call it data, whatever you want. If you're doing software engineering, I wouldn't call it data. So this is just, so it's me, like I'm reacting to this is my live analysis of what's going on in my head. So it's one of the things that sticks out to me is that I don't like the name of this variable, but hey, I'm a software engineer. I'm not a data scientist. I've seen how they do things. Okay. So it's called, see, I can't see it there. So I have to sort of remember how to type. I can remember what it's called. It's called an ND array, right? And how does it work? I guess, am I standing in a weird... Oh, it's because of my microphone. So I don't know. Standing in a weird place. My keyboard's not lined up. Okay. What happened to my life here? Let's get my microphone better. Stand in the center of my keyboard and not type all over the place. I don't know. Okay. So it's called ND array, and then you're going to... That is a method or whatever, function in the NP namespace. And now we're going to take a regular array and pass it in. So they pass the array right in there, but I'm just going to make my own. So this is why this can't be called data too, you know what I mean? So let's just make up some data that we might have. Let's just call it scores, right? So we're going to have a multi-dimensional array called scores, and it's going to be like 23, 14. Let's make them bigger numbers, or let's make them, let's make them decimals. So like, yeah, and .1234 and .45, whatever, and then we're gonna have another array. It's kind of like how the example was, and I'm just typing in random numbers, and we're just gonna see if it works, right? And then I'm going to type into here scores, and then we're going to just show data. Okay, the list cannot be interpreted as an integer. Well, what's going on here? This had lists, and they certainly weren't integers. Okay. Oh, okay. This has to be... This is an array of arrays. No? All right, so what happens, let's say I don't use scores like that. What happens if I just take this, because I don't really see, I don't want to copy cells. I just want to copy this right here. Why wouldn't you let me just copy this? Control C. Let's try here. Okay. So this should work, right? Uh-huh. All right, so this doesn't work, and we don't know why. It says the list object cannot be, but... So here what we do is, now it's time to come to our NumPy documentation and learn about ND array. So I'm going to go to the API reference, array objects, n-dimensional array, ND array. Now, I haven't looked at this before. I'm just using my brain, and I'm like, okay, well, what makes sense? Contains item of the same type and size. Oh, hold on. People are texting me. What is going on here? Always, people want to text me while I'm trying to do stuff. Okay. So if we look at how they created here, it looks like they gave it a type. And again, I'm not trying to understand everything about this now, but I am trying to dig in a little bit deeper now as I read the book and what am I looking at here? Let me comprehend what's going on. So it has a shape. I'm cool with that. Usually a fixed size. What is this second argument here? Constructing arrays. ND array. Array creation routines, or by using the ND array constructor, which is what I'm looking at here, which is a shape, a data type, a buffer, an offset, blah, blah, blah. Okay. Internal memory array, layout of an ND array is probably not something that we need to worry about, So array creation. Okay, so there's different ways you can create the arrays. You can create it like from some values. Okay, so from existing data, I could have said array, right? So what if I did this? Hold on a second. That's what this did. This did array. So this is my problem. I'm trying to, this code is np.array, and what I had was nd array, because I knew that it was an nd array. And what this is telling me is that array is actually a way to create an ND array, I think. Create an array. Yeah, it returns an ND array. So array is a function that returns an ND array. So you see how by trying to make it work, I just mistyped something because I didn't copy it, right? I did not just copy and paste this, and I didn't even look at this while I was typing. I did my best to do it from memory. I remembered that in NumPy there's this thing called the ND array, and what I found out actually was that there is this routine called array. So this is actually a function that returns an ND array if you pass in. And that's why when I looked at this, I saw that we were passing in here. Oh, and this is actually .array as well. So now I learned a little bit. So what we do is we say NumPy array, and we can make this go back to being scores. This is what we're trying to do with our examples. We're not trying to solve all the exercises, but we're trying to interact with the code a little bit and just go through the examples a bit. Now I've got my array. So now we have the array. We can do stuff with it. NumPy stuff. Cool. And we can write mathematical operations like times 10. Yeah, that's cool. So let's do data plus data. And it adds each element going through. Now that could be different. Like for instance, right? This can be, how do I make a new cell? Okay. I just guessed. It was Shift Enter, I think. That's what I typed. Okay, so if I have a different one, right? Like a Python thing. Well, let's just say this. I still have scores here, right? But what happens in Python if I do scores plus scores? See, it's different. So in Python, this is concatenation. Scores plus scores on a Python array is going to give me 2 copies of the array, whereas scores plus scores on a NumPy array is actually going to add the arrays together. So this is how we engage with the material, experiment, and learn. And we go quickly. We spent enough time on this array thing here. We get the idea. There's plenty to learn about the array. We've got that. What else do they want to introduce us to here? Oh, they have a shape. Oh, look at this. Look at this. It's just like J. Well, I'm saying it's just like J, but it's because J is actually just like math, you know. And then, but my knowledge of math is coming from learning J. So, but I say just like J because I'm relating it to things I know, right? I'm not trying to make a factual statement. I'm trying to make a statement about like how I understand what's going on. So let's say, yeah, data.shape. And is shape an attribute or a method? Now, I don't remember if shape is an attribute or a method. I'm going to guess that it's an attribute. And there we go. We get it back. If it was a method, it would have parentheses and would not work because it's a tuple. So here we go. And we've got it. And then we can worry about things like, well, what about when we want to add together data of different shapes? What does that happen? And that gets into that idea of broadcasting. That's what I think basically broadcasting is like, well, what if I want to add together arrays of different shapes? What do we do? That sort of thing. Okay, cool. So here I just went ahead and looked at this. And here they tell us you can create an ND array using the array function. So I would have gotten to this information by reading the book, but by jumping ahead and learning it on my own, whatever, now I have much better chance of actually integrating this into my real knowledge, you know. Okay. So the array function creates ND arrays, accepts any sequence like object, including other arrays. So now let me just try something because I want to learn, right? Let me do this. Let us, we'll leave that stuff where it is, but let's go ahead and it said any sequence like object. Well, what about a generator? And how do I make a generator stop? You know, well, we can have a range, right? It'll have a range from 0 to 8. Okay. And then we can have an array. And let's just say I for I in range, just for now, right? Now we have that. And now let's just say I squared for I, and now we have our squares, and now let's turn it into a generator. Just like this is just like we saw in the examples in the book earlier. We're going to call this squares equals. That's it. There is no output or anything like that. If we just say squares. Now we have a generator object. Okay, cool. So now let us say the square data is going to be an NP array from squares, the generator. And then we'll take a look at the square data, and of course it'll work. Oh, it doesn't work. I mean, it works, but so you can have, see, this is why we do the exploring, because who would have thought? I was picturing that and this is why I made it range 8, because I didn't want it to be stuck forever, but the NumPy people are smart. They realize this could happen, right? Because you could have a generator that goes to infinity. That's sort of the point of generators. It's like a lazy evaluation thing, right? It's kind of like something we pull in from like Haskell. It's like, oh yeah, we can have an infinite sequence, and we'll just use as much of that infinite sequence as we need. And I think that J does a similar thing. So what we're saying is, I was thinking, okay, if we have this generator, when we create the NumPy array, then we will need to evaluate, like, we'll actually have to go through the whole generator and turn it into like an actual array and then make the NumPy array from it. But no, NumPy is cool. They're like, yeah, no worries. We just have this array. He's fine. This array has a generator object inside of them. Well, what if I wanted to do now square data plus square data? What if I want to add my squares together? Does it all have to be evaluated now? Oh, you can't add together a generator and a generator. So how does this work? Okay. So we have to, so the data type is object. So we're going to have to, that's enough going down this alley, but we got to like wonder, all right, well, what's going to happen with this array that has a generator inside of it with a data type of object? What can we do with it? How can we make it usable? Right? Man. So, yeah, I don't know. We'll move on with the book. A lot of questions about this guy here. Okay. Creating ND arrays, we use the array function. Okay, nested sequences, like a list of equal length lists, will be converted to multi-dimensional arrays, blah, blah, blah. 2 dimensions, and the shape is 2, 4. Yes. We're cool with that. Inspecting the end dimension and end shape. So, yeah, the dimension is like the rank. It has a rank of 2 and a shape of 2, 4. So we can put that back here. We can say data.shape. Whoa, what is that cursor? Oh my God. I know. I want to edit this. Data.shape, and we can say data. What was it? ndim? Yeah. 2. Oh, shoot. This line here is just going to be the last thing that was evaluated. If we want to see them both, we want to have a print statement here. All right, cool. Data types for ND arrays. So we're going to be getting into that. Okay. So here we're talking about these other ways that we can create it, like np.zeros, and we saw that here in the array creation routines. So we have all of them here. One's on the diagonal. That's cool. We got all that stuff in here. Matrices, that's what it's called. It's not called a multi-dimensional array. It's called matrices, a matrix. And that is math, the matrix class. I don't know. Wait, what's the difference between... I really don't know. So let's not get into my lack of mathematics knowledge, but not at this point. What's the difference between an ND array and a matrix? Like, it says interpret it as a matrix. How is that interpreted? How is that different? This looks like, I don't know. Probably there's probably more rules about a matrix, like about like the shape or something. I don't know. It's something for me to wonder about, which is how we learn faster. All right. So you give it the shape. It's just like J. Just be like, give me this thing. Here's the shape. We could do that. I really shouldn't be pulling up J, but since I don't even remember how to do anything in J, it'll actually be interesting to see if I could remember how to do this. So, hello? How do you run it? Okay, Control Enter. Okay. And how do we clear it? Control Shift T. Okay. So, how does J even work? What's the assignment operator is equal colon, right? Yeah. 5. Okay. So N is 5. So we'll say I wanted a bunch of zeros. I think you can do like 0 in the shape of 4, 5, something like that. Oh, that didn't work. Why didn't that work? It should. It's something like that. Oh, I'm just missing. No, that's not. I don't want to look up the J. If I look up the J documentation, I can do this in like 2 seconds. I know that you can say, give me an array in a certain shape. Like for instance, if I do I.5, I'm going to get oh, it's because there's no parentheses. It's because there's no parentheses, right? So now if I do 5, 5, I'm going to get the integers in the shape of 5, 5. Okay. But what if I said I just want ones? So I want 1 in the shape of 5, 5. Wait, something wasn't right there. Something's not right in my verb here. But all right, it's okay. I don't really need to know J and all this at the same time right here. It's been like a little while since I looked at J. But you have this same concept. Just show it again. We'll hear just with the integers in the shape of 5, 5 is going to be the same kind of thing as here. It's like it says 3, 6. Oh, we could do it like 3, 6 so it looks the same, right? If we say the shape is 3, 6, we get back 3 rows, each with 6 columns, just like we have here. And here I'm using I, but there's other ways to create arrays. I just don't remember the verb because J has like an ungodly number of verbs that you have to remember. And I don't want to pull up the J documentation because it's just a distraction, but it was something just to help me comprehend what's going on here and have fun remembering some of my J stuff. It could contain garbage values. Let's remember that. VLC. Okay. These are some of the important ones. So array, as array, a range. Okay, so a range is like I. Integers, right? So, okay, so like I know, for instance, that I can do... Wait, can we do a multi... This is my question. Can I do range with a shape? You know what I mean? I better disclose this. I can do a range like, 0 to 8, and I'll get whatever. Or I won't, because it's got to be np.arange. Okay. So I can get this. But what if I wanted that to like come back in some shape? Now, I don't know. And at this point, it's like, well, we don't need to guess. This is where we do look things up, but we just look them up in the documentation. So I come here and I know, okay, my array creation routines. Inside of that, there is a range somewhere from shape or value, from existing data, numerical ranges. So a range. So maybe I need to use something like mgrid or ogrid. I don't know. Or mesh. No. I probably need to combine it with another function. Yeah, it has a start, stop, step. That's it. It does not have, like. I don't know if like means something like I can create it with a shape, but I'm just going to think no. I'm going to think probably if I want things, yeah. I think that I don't see any examples. So if I want to create some like a range like I did, I can't do it. I closed it. Like I did with the integers verb in J. I probably need to combine a range with another function that like takes it and reshapes it. There must be some concept of reshaping, like array manipulation. Is there a reshape? Oh, here it is. See? You ask for it, and there it is. So, and then it just says, okay, so this is a function we got to pass. It's not a method that we're going to chain. It's going to be a function that we do in here. So what I can do is I can call np.reshape, and then I give it my array, and then I say like 3, 3, and I think it's supposed to be a tuple. I don't remember. I think I need to give it a tuple. No. Didn't I shape something earlier? No, I didn't. I haven't shaped anything. Gives a new shape. Well, let me look at an example. An int or a tuple of ints, and the order is optional, so it shouldn't matter. So what does my error message say? Cannot reshape an array of size 8 into shape 3, 3. Okay, so there's a problem with my sizes, but I thought that if it was size 8, it would actually, if that had a 0 to 8, it would be a size of 9, right? Isn't that how it works? All right, but anyway, now we got it. Oh no, it's just me being bad at math. 0 to 8 is not inclusive of this 8. It is exclusive. So 0 to 9 gives me, because this is the length. This is not the stop, this is the length. So start at 0 and give me something of length 9, and now I got the reshape. So that's what I was trying to do. That's cool. That is cool. We are learning NumPy. Okay, so we're able to create these arrays now. What the fuck is n-dimensional? Thank you. So that we can create n-dimensional arrays. So long this afternoon, I didn't know what that stood for. Now I do. Again, look at your documentation. Learn the proper words for things. Okay, n-dimensional array. The data type tells us, and will this do? Yes. According to this will do type coercion, or I should say casting, for us. So this will cast these into floats. Okay. And I'm not even going to really care about that much more. It's fine. Okay. So arithmetic. Well, we already saw plus. Times is going to be the same. NumPy users call this vectorization. Right, so arrays are important because they enable you to express batch operations on data without writing any. Yeah, exactly. I was like wondering about when we get to the here, conditional logic as array operations, but here we're going to talk about doing arithmetic without having to do for loops. Yeah, it's like a map, basically. And we call this vectorization, actually. But in Python, I think normally, I think you would do the same thing using like map. But the thing is, in Python, you don't use map. And honestly, I don't even know. I know you can do it in JavaScript. I know you can do it in Haskell. There must be a map in Python, I'm almost positive. But the thing is, you never use it because you use array comprehension. That's the thing. And the underlying implementation of map, it might just be syntactic sugar, right? Whereas I think what we're saying is in NumPy, it's not just a syntactical thing that you can do it. They're actually is like a more efficient implementation of arrays where you don't have to loop through to apply these things. And however that's done, I'm sure there's like some really smart people. It would probably be really cool to read the NumPy check it. So actually, we're not going to look it up. We're going to come here to NumPy. Boop, 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 boom, and they have a GitHub link. Okay. So we can come into NumPy, and let's say we'll start by looking at core. See what's in there. And this is in Python? Wait. Okay, hold on. How does it work? How does it? We would learn a lot by reading this code. Yeah, here's the C code, right? So I'm not even going to try to, this is like beyond like what I can get into right now as I'm trying to keep myself on task that I am working my way through this book. But, this is kind of my process is like, let's pull this up and just see what's going on in here. And somewhere there's like an implementation of an array, we'll just take a look at array assign. And let's just see if we can make any sense of it, Now, this is for copying arrays. Anyway, so there's going to be really cool C code that somebody really smart wrote that allows us to have these more efficient data structures that don't come built into Python. So that's awesome. Awesome. Math module. That just sounds like there's probably some real shit going on when you have the math module. It's just like math. This just has math in it. This is just math. No, it doesn't. It doesn't. I don't know what it has. No, who knows what these things mean. So I've been using a little bit of Visual Studio and like looking at it in GitHub. It's like so frustrating to not just be able to hit like F12. And I am absolutely going to fix up my Emacs so that I can just say like go to definition for whatever, I'm sure for Python you can do it with the LSP. Doesn't matter. So we're way sidetracked now, but NumPy is here. We can look at the underlying NumPy code. And that's the sort of thing we want to do for experts. Now, if I was like a full-time data scientist, I would absolutely be reading the NumPy library code, all the time. I'm not going to use NumPy that much. I'm not a data scientist. I'm not even like all that interested in, I've been using Python for a long time. I'm not really interested in that being like the next step in my career where I do tons of Python, although it's possible because I do like Python. It is like my strongest language probably. But I'm probably, whatever. I don't know where I'm going to go. I might love this book so much that I decide I have to do data science. Whatever. I've certainly done some machine learning recently. So it's just all my internal thought process, and I'm making the video so that you see like you should be making similar videos for yourself. And the reason for making the video is so that you could just think all of this while you're reading, but it's so much more explicit and concrete if you force yourself, in your mind is like super fuzzy and multi-dimensional, but to say it out loud, even more so to write it, but at least to say it out loud and record it, you are linearizing things. You're putting it all, you're flattening everything, and you can no longer escape fuzzy thoughts, Anyway, the point is to learn, and I think it's a good tool for learning to force yourself to record it, even if you never share it with anybody. Although even better if you can share it, because it forces you to like be present and professional while you're recording. All right, so we can do the arithmetic. We can multiply, we can subtract. We've already tried this stuff. I already understand this. I'm not here teaching it to you, so I'm not trying. Like, I understand this because I've done J, so I get it. Comparisons, interesting, no problem. All right, basic indexing and slicing. Oh, we're going to get to the Boolean indexing. So it's just pretty standard stuff. Okay. Okay, so there's not a copy made. The data is not copy. If we slice it, that's it. We sliced our array. We're not getting a copy. We're not getting back a slice like Python does. We have sliced the existing array. The old array is gone. Okay? This is an in-place operation. Yes, but it's because NumPy wants to work with huge data sets. You have to call .copy, of course. With higher dimensional arrays, you have many more options. Oh, cool. Wait, what is what does this mean? What are they telling me here? We can access the individual elements recursively. Okay. Yeah, I'm okay with this indexing like this. What about slicing though? Can I slice like this? We should probably write some code to try to slice some shit like this, but I'm feeling a little bit lazy about it. So I'm just looking for an example. Are they going to tell me that how can I slice? Index with slices. Wait, what was this indexing up here with? I thought this was a slice. Yeah. So they're showing me slices, and then they're saying, was this like just, all right, this basic indexing, and then we're going to get, they just say, okay, now we're doing multidimensional, higher dimensional, and now we should be able to slice a higher dimensional array somehow. Okay. They can be sliced with the familiar syntax, 1, 6. But this is a simple array. This is a one-dimensional array. Here's a two-dimensional array. And we're going to say, get me elements 0, 1, 2, or just 0, 1, okay? And we're going to get it. But can I slice inside of it? Yes, we can. Okay. That's cool. So I didn't have to write this code because they did it for me. So I was thinking like, okay, I want to play this and write it. But I knew that it was just more tedious, and I didn't really feel like doing it, that if I just saw that it could be done, that was enough for me. I understand. If you don't understand, you should spend some time writing this code. I get it, and I don't feel like writing it. Okay. Lower dim slice. It's a 2D array where I got the first thing, and then I cut out the up to the second element. So I got the first thing. Wait, where's my array 2D? Here's my array 2D. So I get the first thing, and then I'm going to say, get me from the beginning to the second thing. So I should just have 1. Oh, I just have 2? Oh, I don't know. I just screwed up with my understanding of the slicing syntax. Oh, yeah, this is 1, the first thing until the end. This should be from the beginning until the second thing, I thought. I don't know. Also, I wasn't paying attention possibly to what operations were being done on this thing, so that's probably why. So at this point, array 2D actually, because this is in place, this is what was screwing me up. I went back to the original one, and no, it's not the original one, because when we did this operation, we did actually slice that, so the original one's gone. And now what we have is just this, and then when we say, okay, give me up to the second one, and give me from the first thing on, now we have this. So my reading of this code was correct. I said, okay, give me the first one, the first element, and then in the first element, give me everything up to the second element, which basically is another way of saying the first element. We should get 2, which is what we got. I was just looking at this, which is why I thought it was 1, but it was this, which is why it's 2. Similarly, I can select the third column. There's nothing left in this array. I can select the third column, but only the first 2 rows, like so. Okay. Right. Give me the first 2 rows and give me the third column. Give me, yeah, perfect. But hold on now, because when I did this slice, see, I don't think this is correct, this code. This book's not published yet, but I think that my array 2D here now looks like, oh, this is the shape. It's a tuple with 1 axis. Oh, okay. So what does this look like? All right. Whatever. I have an idea, a pretty good idea of how all this works, and we're not going to try to like spend forever understanding this in minute detail. I've got the idea. You can do this indexing inside of indexing inside of indexing and slicing inside of that and so on. Cool. We can do multidimensional slicing and indexing. But what is Boolean indexing? That's pretty cool. I'm not really I don't know I can't even guess what that would be. Oh, is it like a bit mask? Okay, here's my names. Here's my array. Names is this array. There's my data. What is this? What does this even mean here? Okay, so I get it. I have my names. We didn't learn anything from this. Okay. All the rows with Bob. Names equals Bob. Ah, yes. Yes. Okay. I got this. I understand this for sure. And then this Boolean array can be passed. Okay. This is also something you would do like in J. Okay. This is really cool. This is one of like array-based programming is just cool. I like NumPy because I like J and I like the array-based. So basically, what we're saying is, it's kind of cool because I want to say this out for my own. This is for my notes. I'm trying to like think through things, right? Like so many times you're trying to build in imperative programming like the recipe of things. Do this, do this, do this, do this, and it's boring, right? This is cooler because you are making these transformations on the data and then combining them to produce the same result. So instead of like saying, here's my linear process, you're saying, well, if I transform and combine my data in this way, I get the same result. Basically saying, let me find all the Bobs, true, okay? And then given that kind of mask, let me apply it to this array and I will get true and true. And that's what they've done here. So I can say data names equals Bob. Wait. I got names equals Bob produces this array. Oh, and then this is my data. Right, I understand, yes. So names equals Bob gives me this thing, and then I say, okay, give me it everywhere where it's true. That is right before I started reading this, what I kind of thought Boolean indexing might be like when I saw this, and I said it's like a bit mask. Right, it's like there's a way to select the data like that. Okay. It's not a bit mask, but it's, it's a kind of a similar idea. And I index the columns too. I don't care. You're just, adding in. I don't care that you can index it. Of course we can. I guess it's kind of cool to see like these many operations that we can sort of chain together inside of the array indexing. You can do a Boolean indexing, and then you can do this, this regular indexing, regular slicing. You can use a negation, okay. The squiggly, the tilde, you can invert the Boolean array. So I can say this is not, right? So I can say, show me all the names that are not Bob, right? And I think you could probably do a tilde in front of the array, but that's a little bit weird. And this is probably a little bit cleaner. So show me all the not Bobs. Okay, here they are. So filter out Bob. One was select Bob, one was filter out Bob. Now we have, oh, so they use the word mask. That's what I've been saying. It's a mask. Okay. To select two of the three names, combine multiple Boolean conditions. Yeah, show me Bob or Will. Now, so, okay, so this or, check it. This or is doing an or of these two arrays. So it's going to take the two arrays and do an or on them, meaning that if there's a true in a column for either array, it's going to be a true in the final array, right? It's going to be true or false, true, true or true, false or false, false or true. It'll get smushed down to be whatever. Okay. So we can do an or on arrays and then make that our mask and then use that to select. And now it's starting to make a little more sense in my head how we're going to do this array-oriented programming where we do conditional logic, because here we have conditions, right? And or and not. We have logic, and we have, like here, a condition. So we're on track. Will I get there? I don't know. I'm running out of time. But it's something for today. I feel like I'm learning. All right, fancy indexing. Let's get this, whatever. Oh yeah, less than whatever. Okay. And you can set whole rows. Okay. So if it's Joe, make it equal to 7. Man, everybody can just use NumPy. Like we need, this is what we need. A web framework that uses NumPy so you can do something like APL in Python, right? Or just like, we don't even need NumPy because it doesn't have to be numeric. It's just about we need like a library that does like these NumPy style array programming in Python, or APL style array programming in Python. Fuck it, we'll just use APL, right? Oh, we build APL into Python. Right? I think we can do it. I think you could implement APL in Python so that you would then have access to all of the Python ecosystem, but you could write your code in APL. Something like that. And at that point, you're probably better off doing it on JVM or .NET, but, whatever. Okay. None of this it's not important. Like the result of these ideas are not important, but the fact, it's just like letting my brain process stuff, right? That's how my brain's processing. It's thinking like, okay, what could you do with this? Fancy indexing is a term. That's the real term. It's in the book. To describe indexing using integer arrays. Okay, so you had a 4x8 array. Got it. 8x4 array. And, if you do for I in range 8, array I equals I. So this has a default data type of some kind of float. All right, fine. So I've got my array. This is how I built it. I feel like there should be a better way to build the arrays like that, but that's okay. So, yeah. So now my array index is getting a list. So if this was not inside of a list, this would be like a recursive index. It would say, okay, get me element 4, and then from element 4, get me element 3, 0, 6. But what it's saying is this is the first thing, and I want you to get me elements 4, 3, 0, 6. So that's pretty cool. I think we could probably do some cool stuff with that. Okay. This is actually, I'm really happy that I'm doing this now because this is such a natural extension of what I was learning in APL, which I've talked about a lot, but it really fits in with what I was doing. Okay. Passing multiple index arrays does something slightly different. Good to know. It selects a one-dimensional... Oh, here's that reshape that I looked up before. Okay. All right, here's the... I was like, where's the code I'm looking for? So it selects a one-dimensional array of elements corresponding to each of the tuple indices. So what I think this means, it's going to say select 1572 from 1 select 0. There it is. From 5 select 3. So 0, 1, 2, 3, 4, 5, 3. Oh, 0, 1, 2, 3, 23. Right, okay, I got it. Reshape, I already know about it. Oh, reshape was advanced. I was already advanced. I already saw reshape an hour ago. Okay. Okay, transposing arrays. Whatever. I'm going to reshape again. So this is how you have to do it. That's what I did. Isn't that what I did? Oh, you can call it as a... You know, you could have... They say that it's the function... Hold on, let me go to these docs. Because they showed me like a reshape like this. Oh, I guess because these are all NumPy objects, you can chain all these things together. And then if I had looked at the docs for like more than 1 second, I would have seen that. And I'm actually going to go ahead and fix my notebook so that I like the way I do it was possible. Because when you look at the docs, what they showed me here was that your first thing you're getting is your array-like object. Oh, no, not that. I'm sorry. But that's still what they showed me. The first thing they showed me was that you're getting your array-like object. And then you're getting the new shape. So that's like, and I thought I mentioned at the time, I was like, oh, so you don't chain them together. But you do chain them together. Where's the notebook? I don't know what the notebook looks like in the... Wait. Oh, it's in its own window. Okay. Woo! Okay, so I can redo this a bit here. And just reshape. What was it going to be? 3, 3. And get rid of that. And that code looks like a lot nicer to read it that way. Just looks nicer. That's all. Okay. But now, like when I look back at it, I'll remember you can write it that way. Transposing and swapping axes. Axes. I like to say axes. Axes. I like to say axes. Okay. Special T attribute. Just transposes it. That's fine. And you can compute the inner matrix product using NumPy ... Here we go. So you have this array translated. Yeah, I'm gonna. There's nothing programming wise here that I'm worried about, so I'm just gonna take their word for it on whatever a matrix product looks like, inner matrix products. I'm sure I can learn this, but just I'm running out of time. It's not what I want to learn right now. I'm starting to get tired. Okay. The infix, wow. That's wild. Hold up. Now we got some crazy shit going on. You've got me here. They have introduced an operator. Cool. That's great. I think it's cool. Like it shows kind of like what's cool about Python. That these guys are able to add an operator? Like, or am I missing something? Or did these guys just create a new operator in the language? Is this Lisp? What are we doing? All right, so usually I see the @ symbol as a decorator, right? So if we look in here for decorators, right, we're gonna see this. You can use this syntax with the @ symbol, but how did NumPy just put an @ symbol and then they don't have anything like? Oh, it's called the infix operator. Or is this a part of Python that I don't know about? Maybe this is Python. Okay, maybe it is Python and I'm just like naive or ignorant. Yeah, okay. Oh, a dedicated infix operator. Okay, so here we have a pep about it. At star. Okay, so this is in the language. I just never came across it because it is specifically for matrix multiplication. And I'm less impressed with the NumPy people thinking that they had somehow hacked an operator into the language. It was put in via the PEP process. Whoo! Okay, I'll look into it more further later. Okay, and we have swap axis. Fine. We're just gonna flip the thing over. All right, I gotta stop here. I'm out of time, and it's been an hour. That's long enough. I've only made it to 4.2. You know, I would have liked, but all 4.1 was pretty cool. I mean, this was like, I think this is like basically the whole thing. And this 4.2, 4.3 is going to be fine. There's just saying there's all these functions you can do. 4.4, I think builds on 4.1. I love it. I'm all about this array-oriented programming. It's cool, and it makes me more interested in Python, whereas like I've kind of lost interest in Python because it's kind of like, you know, it's not Haskell, it's not J, it's not even, you know, a statically typed language, although there's type annotations. Okay. All right, I'm gonna pick back up and reading 4.2, but I feel like next time I'm gonna be able to get through most of this and then get into pandas a bit, which I'm not sure if there is a ton of stuff. You know, I think it's gonna be a lot of it built on top of like NumPy knowledge, so it should probably be cool. This crap is just, I'm just going to skip it basically. And we're going to get into this. All right. These are my notes. Read the book. Make your own notes. I'm just doing this to help and provide an example. But, you know, watching me is not really helping anybody. The best it can do is if this gives you some idea of how you can approach information in this kind of way where you're very active and investigating, stay focused on your task. Even if I'm going off and like looking up some source code or whatever, I'm still like, I'm not checking Facebook, you know. I'm taking these diversions, these tangents, but I'm still focused the whole time on learning, you know, this topic. Cool. Woo! I don't know why I say that. So, good luck. Have fun.